Hello there, this is my first attempt at making a Pure Data tutorial. I've been working with Pure Data for about 5 years now. I use it for sound design, art installations, and live performances. And the idea here is to rather give you a really quick introductory tour of what Pure Data can do. I think there is already enough really good material online if you want to get started with Pure Data. And I don't really want to make another tutorial on how to make an oscillator go blip. So I suggest we patch together. I talk about some concepts related to Pure Data, to music, to composition, and then in the end you might get something cool out of it, like a cool device you could use for your composition or live performances, for example. So here's the obligatory introduction part, which I'm going to keep as brief as possible. And if you already have some experience with Pure Data or with coding in general, then I suggest you just skip it. Yes. In order to get started, you have to have your version of Pure Data downloaded. I'm going to leave the link in the description, but you could also go online, look for Miller Packard. He's the creator of Pure Data. Then you go to his website, and here's the download link. You make sure you download the current stable release for your platform. In my case, it's Mac. And then, yeah, it should be really straightforward to install the thing. I'm not gonna get into that because you already have it installed. And then you boot it up. That's how it looks like. This is our console window. I'm going to clear it for now. Yes, so we press Command, comma to go to the preferences. Here's the input MIDI devices and the output MIDI devices. And I choose my Arturia keyboard. You can also set up Pure Data to output MIDI to other software, which is really cool, I think. And on Mac, it's really easy. You just use the built-in AIC driver. I will get into that later. So let's set up our audio preferences. This is our driver. This is our sample rate. This is our block size. It's the same as in any audio software you use, like Ableton or Logic or anything else. I will talk about what this actually means later if we get to that point. And here's our input and output devices. I just use my headphones for now, but you should have your audio interface if you're using one. And then you can set up a number of channels here, which is really cool. That means you can create multi-channel audio installations, for example. And then here's our input. Here you can see it offers an option of my laptop's microphone and the microphone I'm using at the moment. And there is also black hole. We'll talk about that later as well. Okay, so now we're going to create our first project, which we press Command N for. And here's our canvas, the blank white void we're going to fill with our patch. And yeah, as you might know, Pure Data is the visual programming language, which means instead of dealing with lines of codes here, we're going to be dealing with object boxes, and we're going to connect object boxes with cables in order to do stuff. It's a lot like Max MSP, if you have experience with that. And the reason for that is that Miller Puckett, the creator of Pure Data, worked on MaxMSP as well before moving to Pure Data. And unlike MaxMSP, Pure Data has a really simple user interface, but on the bright side, it's actually free and open source, and you can port it to many devices, for example, like your tablet or smartphone, which I think wasn't the case for MaxMSP for a while. At least that's what I heard. All right, here we're gonna go through the Hello World routine. And we start by creating our first object in Predata. We press command 1, and here's our object box. We type in print. For those of you who don't have much experience with coding, like me, we basically just created a tiny program inside of Pure Data that's gonna do stuff for us. And for those of you who have some experience with coding, we basically just called an instance of a class, as I understand how it works. So we have our print object, which is going to print our message in the console for us here. And now we have to provide the message for the print object. And we do that by creating a message box. We press command 2, here's our message box. We type in hello world, and then we connect it to the print object. Yeah, I move things around a bit, you don't have to do that. Now, you have to know that Pure Data has two modes. One of them is the edit mode, in which you create your code and debug it. And then the other one is the performance mode, in which you interact with the user interface of Pure Data. So in order to print our hello world message, we go into the performance mode by pressing command E. And now we click on the message box, and here's our message getting printed in the console. Let's modify this. So we're going to introduce a new object. It's going to be a metro object. Again, command 1. And we give it the creation argument of, let's say, 1000 milliseconds. That means that we're going to create a metronome that is going to trigger the hello world message with periodicity of 1 second. We connect it to the hello world message, and then we have to send a message to the metro object to get it started. Yeah, I'm going to clean the console. Then I'm going to create another message box, type in 1, and connect it to the metro object. Now we go into the performance mode, we press on 1, and every second we get the hello world message. Okay, so now if we want to stop, we create another message box, type 0 in it, connect it to the metro object, and performance mode, stop. Yes, it stopped. So now we're going to connect a GUI element, which is going to be a number box, to our right inlet, so we can change the speed with which hello world message is getting printed. We type command 3. It's a nice number box. We connect it to the right inlet, and then we can type in time in milliseconds that we want. Let's say, I don't know, let's say it's going to be 200 milliseconds now, so you can see the difference. So again, clean the console and initiate the Metro object. Yeah, see, now it's much faster. Okay, and then clean the console. You can adjust the speed of our Metro object by simply holding, like left clicking on it and then holding and then dragging, and that it changes the speed. Sorry, I have to clean the console again. Yeah, see, now it's really slow, and now it's getting much faster because we changed the speed with which it triggers the hello world message. Okay, so let's make another adjustment. Well, now, first you gotta know that every object in Pure Data has its own help file. You can right-click on the object, and then here's help, and then you can read everything you need to know about the object and how to use it. Yeah, anything you need to know. Then, as you can see, it takes 1 and 0 as messages to start and stop, and we have an object that does exactly that, the GUI object. Let's delete this and create a toggle. It's toggle. So we connect it to the Metro object, move it around a bit so it looks nicer. You don't have to do it if you don't have OCD like I do. So clean the console, run mode, and yeah, same. If you connect a number box to the toggle, you can see that it outputs ones and zeros. All right, now I'm going to talk about the order of execution in Pure Data. As you might have guessed, everything is executed here from top to bottom. So you send the signal into an inlet or an object, and then it comes out of the outlet, and so on. But important thing to remember that everything is executed from left to right here. So let me create a new object which is going to be called bang. It's a GUI object, BNG, that you can click on, and whenever something comes into its inlet, it lights up. It's very convenient for debugging when you're trying to make sure that something actually works and sends signals. And also it outputs bang messages. I'm going to connect it to print, and you can see bang messages. These are basically the messages in Pure Data that tell objects to do something, like nothing specific, just do whatever you do. So now, clean console. Now say I want to output 3 different messages with the same Metro bang. Let's say the other one is going to be walk the dog, the dog. And the other one is going to be something else. We connect them all to our bang now. And that's how they get outputted. As you can see, something else is first, walk the dog second, and hello world last. So if we want to explicitly specify the order in which the messages are going to get printed, we use a new object called trigger. We tell it to output 3 bangs at the same time out of its outlets that we're going to create. So trigger, bang, bang, bang. That created 3 outlets. And look, so we are going to connect hello world to the first one and something else to the rightmost one. And we get the same situation as before. Something else is the first, hello world is last. But now, if we change the order, if we connect walk the dog to the first, hello world to the second, and something else to the last, we get this. So, as you can see, wait a second, that's not what I wanted. Yeah, something else is going to be first inlet and walk the dog last. So now walk the dog is getting output first and something else is going to be printed last. Okay, so you don't have to always write trigger bang bang. The object also understands abbreviation. You can just write T, B, B, B for the number of outputs you need. And yeah, here it's the same. So another important thing to mention before we move further is that objects in pure data have hot and cold inlets. Let me demonstrate. First, let's delete our messages by selecting all of them and pressing backspace, and then we're going to create a new object called float, which stores a floating point number and outputs it. And as you can see, same as the metro object, it has 2 inlets, and let's attach a number box to it, which is again common 3, and another one to its leftmost inlet. And now if we change a number in the number box, it outputs our number. And if we connect it to the print object, whenever we change the number in the number box, it's going to print that number. But let's connect another number box to the right inlet, and here we change the number and nothing actually happens. But now, see, it says 16. If we send a bang into its left inlet, it outputs 16. So it's actually quite important for scheduling things in pure data. Say you want your metronome object to output a number, but you want it to output a new number next cycle, not straight away. So now, if you use the cold inlet, it outputs your new number in the next iteration. Alright, now it's finally time to make some sounds and talk about how Pure Data approaches audio processing. In Pure Data we have 2 distinct types of objects. One of these is control objects and the other one is signal objects. The control objects are the ones we already used. Our print object, our metro, or our float, for example. And the signal objects are the ones that deal specifically with audio processing. And it's important to mention that you can easily convert control information coming out of your control objects into the information that signal objects can process, but to do the opposite is not as straightforward. And the way I understand it, again, I'm not a programmer, the way I understand it is that control objects use your CPU, so it's much faster. The response from them is almost instantaneous unless you do some really heavy calculations or do something wrong. And signal objects use your sound card, which is much slower and has to operate at your chosen sampling rate. So yeah, and the other important thing that everything in Pure Data is getting processed in blocks of samples. And if you go to preferences, you can see this is our sampling rate and this is our block size. So this is like a tiny buffer that Pure Data creates to process everything that you wanted to process. And you can adjust the buffer size and samples. It's going to be smaller. If you wanted to respond faster, it's good for your live performances, but if you want to do something that is like really complex and heavy, you might want to make a bigger buffer size. So Pure Data has enough time to process everything, but then it responds much slower. And we actually can calculate how much it takes for every buffer to get calculated. So say we have our sampling rate at 48,000 samples per second, and our block size is going to be 512. That means that in 1 millisecond we process 48 samples, because yeah, it's 1,000 milliseconds in one sample, right? And then that means to process 512 samples, we need 10 milliseconds, which is quite quick, but actually not that quick. Depends on what you want to do. Okay, now it's too much yapping. Let's finally create our first signal object, which is going to be a simple sine oscillator. And I also forgot to mention, because I'm so used to hotkeys, but here in the upper left corner you can go into Put, and there is the drop-down menu with all the objects and things you can put on your canvas, and with also hotkeys written for them. So now we're going to do this. Instead of typing command 1, we're going to click on object, and here's our object box. We type in OSC and then add a tilde. That just means that we're dealing with the signal objects. Every signal object has a tilde after its name. And then we're going to add a creation argument of 440 Hertz, so it's an A. And yeah, here it is. Before connecting it to our output, we need to attenuate it a bit so your brains do not explode, same as mine. I kind of still need it. And for that, we're going to multiply the signal that comes out of oscillator by a multiply object, which is asterisk, and then we add asterisk. And then we add a tilde again, because you cannot actually connect a control object to the outlet of a signal object like we can show it here. So if we just use a simple multiplication object and try to connect it, then nothing actually happens, and then you get the error in your console. Okay, so we are going to multiply the signal from the oscillator by 0. Let's say 0.5 to be safe, and then connect it to our output. It's a DAC tilde object. DAC stands for digital to analog converter. So basically that means that we convert our digital information into electrical signals that we output into our headphones or our speakers. And then now we're going to specify the number of channels we need. I'm going to type in 1 and 2 for left and right. side of my headphones, and then I'm going to connect them both to my multiply object. Now nothing happens, but that's because we did not turn the signal processing on, and in order to do that there are a few different ways. The most straightforward is to go to the console window, and here's the DSP box. We can tick it, and then you can hear our nice sine wave. But something that is going to be more useful to you in the future is that you can actually send messages to objects in Pure Data, but also to Pure Data itself. And we are going to use the message box to turn the DSP on. And now we have to first type in semicolon, then enter, and then we say PD. We're sending a message to PD directly to Pure Data. That is the DSP, and then we say 1. So we turn the DSP on. Then we go into performance mode, and we click on it. And now you hear our sine wave. We can turn it off by typing in 0. But what's cooler, you can have a placeholder in your messages. So variables, that is. So instead of having a 0 or 1, you can just type in $1, and then we're going to create a toggle. And yeah, I'm going to add a number box for that, so we know that it's same 0 and 1 that it outputs. And then, so what actually happens, whatever comes out of the toggle object is going to be substituted here instead of our placeholder variable, that is. And now let's try this. All right, so instead of turning DSP on and off, we probably want to control the volume of our oscillator in some different way. And for that, I suggest we create another multiply object. And the simplest way to do that would be to connect a toggle to its right inlet. Then if we turn the DSP on, it's still silent, and then we can turn the toggle on, and it makes sounds. Yeah, so with signal objects, there is no difference between hot and cold inlets. Everything is getting executed simultaneously. But as you heard now, whenever we turn it on and off, you can hear a click. So in order to make our envelope a little smoother, we're going to use a new object. It's called line. And it creates ramps, and it understands messages. So the first part of the message is going to be the number it has to create a ramp to, and then the second message, it's going to be the time in which it has to reach the destination. So as with the DSP object, we are going to use $1 for the variable, and then we're going to specify the time in milliseconds. We connect it to the line object, and then now our switch is much smoother. All right. Yeah, you can make it longer or shorter. This is still going to sound good without clicking, but as you can see, it's much sharper. Now that we learned about ramps, we're going to build a little synthesizer. I really like Pure Data because it's quite intuitive if you have some idea of modular synthesis. And here I made a little patch in VCV Rec that we're going to recreate in Pure Data. Well, we already did more or less. So as you can see, we have our signal source, which is the oscillator here, and that's the same sine generator here. Then we have our amplifier, and then we have our envelope. And then here, if I press key on my keyboard, it makes sounds, right? So we are going to try and replicate this in Pure Data now. So first thing we're going to do is create a somewhat more sophisticated envelope, and for that we are going to use a similar object to line, which is going to be vLine. And the difference is that it not just understands the value to which to ramp the ramp time, it also can have the delay times. Say we want a delay here of 300 milliseconds before it goes to the next value. So if you don't know if you noticed it, maybe it's a little short, let's say 2 seconds. Yes. As you can see, this envelope here has 4 stages: attack, decay, sustain, release. And the first 3 stages are executed whenever I press the key. So now it's on sustain. And the last stage occurs whenever I take my finger off the keyboard. So let's try to replicate this here. So we have the first 2 stages. That means we need 2 messages. The first message, we're telling our envelope to go from 0 or whatever value it is on right now to 1 to the full volume. So that's going to be start at 0, then go to 1 in whatever it says here, 10 milliseconds, sorry. Then we have to go to our sustain level, which is 15% here. That is going to be 0.15 for us. And then the decay time here is 59 milliseconds. So it goes to 0.15 in 59 milliseconds after, it's really important, after the break of 10 milliseconds, because all of these messages, they're executed one after another, and if you don't keep in mind the time that it takes every message to get executed, then they're going to be executed all at once, and you're simply not going to hear anything. I think that was always annoying when I was beginning with Pure Data. So now we have our attack, decay, sustain phase. Well, that's close enough. And now we have to do our release phase. So the envelope goes to 0 in 100 milliseconds. So this is our second message. And yes, now we are going to replicate the keyboard part. So we want to trigger our first message when we press the key, and trigger our second message when we lift off the finger of the key. For that, we already have our toggle, which outputs 1 and 0. So let's say whenever we press 1, we want to have this message triggered. And when we have 0, we have this message triggered. So for that, we're going to use the select object, which selects whatever comes into its inlet and outputs banks for every argument we have. Yeah, that has to be 1 and 0. So let's add some banks for it for clarity. And nothing happens because it was at 0 already. But now we do this again, and I mean, that's close enough for jazz, right? Okay. And next thing we're gonna do, we want to actually use our MIDI keyboard now, and we want to send the pitch messages to our oscillator object to change the pitch. So by default, it understands messages as hertz, and we probably want to send it MIDI messages. So we're going to create a new object that is going to be called M2F, which means MIDI to frequency. That is going to convert our MIDI information into our frequency information, like C. We're going to type in 60, and this is going to be our middle C. Now nothing happens because we have to trigger our envelope, but here's our middle C. Yeah, let's connect the keyboard now. So in order to do that, we use the note in object, and here we right click on it and go to the help file to make sure our keyboard works. That's the sound coming from VCO rack. I'm going to turn it off. Now we don't really need it anymore. And here we have 3 parts of our MIDI message, which are channel, velocity, and note. And they all go from 0 to 127 because that's the MIDI format. And we're going to use the velocity information for our envelope and the note information for, yeah. Then we need the first outlet and the second outlet. But here's one thing that we have to remember here, that our select object only understands 1 and 0 messages, but what MIDI object outputs, our velocity information can be almost any number between 0 and 127, depending on how hard I press the keys. So now we're gonna do some logic on this. So we want it to output 1 whenever we have the key pressed on, which means that whenever we have our velocity non-zero, we want it to output 1, and then whenever it's 0, we want it to be just 0. So we're going to use not equal to, the not equal to 0, that is, and it's going to output 1 whenever this condition is true. I'm going to delete toggle from here, but disconnect it for now and connect it to our logic object. Yeah, so whenever we press the key, here we have 85. 85 is not equal to 0, then it's true, then we have 1. And then now we have 0 when I take my fingers off the keyboard, and 0 is actually equal to 0, obviously. So this is not true. Then the object outputs 0. The other way to do it would be, let's say, the number it receives is larger than 0. And it kind of does the same here. See? I don't know, for some reason I prefer not equal to, but it really doesn't matter. So now, let's see how it sounds. Well, it kind of works, but there are some things we could improve. First of all, our first message doesn't have to start with 0. We'd rather just start at whatever value it is currently and then go to 1, because otherwise we have clicks again because it jumps to 0 whenever we trigger that message. So, and let's say we want the release a bit longer, but that's just my personal preferences. And let's make it a little louder, not too loud, so. Yeah, so it works. And the last thing I want to mention, you can also send the ramps from V-line or line objects into the oscillator object, and it's pretty cool for FM synthesis, but for now we're just going to use a little ramp whenever we send the new node there. So it's going to be $1, and yeah, let's make it pretty long now, but you can adjust it however you like. Yeah, just tighten it up. So now we have there was something weird there. I think that's because I press more than one key at once, and it doesn't understand the polyphonic keys yet. You have to add stuff to that, but we're not going to do it now. But let's make even longer ramp to our OC object, and let's make some intervals now. Sorry. Yeah, see, now it's really, really slow. But we can go weirder than this. Say it's going to be a ramp from an arbitrary frequency every time, let's say 1000 hertz to whatever we're pressing on our keyboard right now. Then we have this glissando effect. Let's see how it works. Oh yeah, the other thing I forgot about is that now our node in object outputs bangs whenever we send a new message. So as you can see, this message to line gets triggered twice whenever we press the key and whenever we take our finger off, which is probably not what we want to do. And there are a bunch of ways to fix this problem. The first one is going to be just adding a change object, which only outputs bangs whenever whatever you send into its inlet changes. So now, as you can see, let's so here node in outputs two bangs for attack and release parts, and change object only outputs bangs whenever we give it a new number. So that's one way. And the other way, if you still want to have your message to the line object get triggered whenever you press the key, you would want to use the strip node object that does specifically that. It just doesn't output the node off message, it only outputs the node on message. So now we have our weird glissando every time we press the key. Now, if you made it so far, congratulations. You can now do the hello world thing and make a really crude synthesizer that you control with the MIDI keyboard. For the next section, I plan to talk about sequencers and drum machines, but if you have any questions for me or you want me to talk about some other pure data related topics, let me know in the comments. Hopefully, see you next time.